Hello and welcome to my presentation about engineering ethics, created by me, Aiden Possum. In this presentation, we will go over the code of ethics used by engineers to create safe and moral objects or engineering products that are used by many people to fulfill a utility. Now, let's jump right into it. Why do engineers need to be ethical? Well, number one, of course, you don't want any killer robots, or even the Matrix, or remote controls grabs. That's pretty bad. So, the engineering code of ethics tries to keep people within line and prevent outlandish creations. But in all seriousness, what follows, without following a good ethical code, it becomes very, very, very easy to create a death trap for unbeknownst patrons or users of your facility, your products, or whatever you're creating to fulfill a utility. And this is not an uncommon event to have disasters. Disasters happen all the time. They're just not always reported on. But big disasters, or notable disasters, aren't all that rare. A couple examples would be the tower on the bottom left there. It was a very close call. An engineering student, while doing some calculations on the building, realized that the building, under high winds, could collapse. And they ended up going and fixing throughout the building. And now the building is safe, but it was a very, very close call with some ethical problems that happened to cause that problem. In the middle, we have the Challenger disaster. It's pretty bad. Killed all the crew on board. And on the right, we have Ocean Gate's Titan. They were trying to submerge to go see the Titanic, but they never returned. Now, let's talk a little bit more about the Titan submersible. What actually happened? On June 28th of 2023, the Titan vessel submerged to go to explore the ruins of the famous ship, the Titanic. Sadly, they would not return in one piece. A structural failure of the hull occurred due to inadequate material selection and insufficient quantities. This caused slow cracking, and it was a very, very poor design. And the reason why this happened was because they broke ethical codes to prioritize lowering costs in the name of innovation, which wasn't actually innovation, it was just stupidity and incompetence. The American Society of Civil Engineers lays out an ethical code that every engineer should follow if they want to be an ethical engineer. When comparing the document to the disaster, one thing that popped out at me was just the very, very first rule: protect the health, safety, and welfare of the public. And they did not do this. They made design changes to lower costs, and they did not provide an adequate safety margin, and then ended in disaster and killed everybody on that submarine. Talking about the Challenger disaster, the O-ring in the solid rocket booster was frozen from the night before, and this caused it to become stiff and bleed hot gases during the launch. This caused the death of all the crew on board. This was caused due to administration pushing the launch even though engineers knew it was unsafe to do so. They even warned administration, and yet this was overseen, and out of the ethical code, they launched something not in the name of safety, and it caused the death of all the people in the top right that you see. Now, how can these disasters be mitigated? And the truth is, they can't be completely eliminated, although they can be mitigated, because incompetence, cruelty, and greed are just human features that we kind of have to deal with. But we can decrease the amount of occasions that they occur with strict regulation, peer review on all vital actions, and a high safety standard of knowledge and competence within the industry. Now, how does engineering and the discourse within the engineering community prevent disasters from occurring? Communication of engineering ideas, failures, and tests are key to the success of the community. Without the sharing of ideas, it is impossible to achieve the common goal of creating a utility that performs its purpose. Communication is key through scientific papers and reports. When can an engineer publish a paper or work on a project that involves safety? There is a level of knowledge and credentials that you need to occur before you're able to work on a project, publish a paper, or something else. So when you publish a paper, you need to make sure that it pushes the bar forward within academia, and otherwise you're just not going to get published. It's a pretty useless paper. And after you publish it, debate will be necessary to test the knowledge and the ideas that you present, which is why it's so vital to share your ideas in the first place, because without a rigorous quality control of your ideas, it's very easy to be led astray and false ideas to be used. So when you publish it, you'll go through a rigorous process where your ideas will be rebutted, and anyone within the industry that is qualified can share their papers and their ideas, and gets this very useful process of science. How to become a safe engineer. Becoming a safe engineer is a learning process. It comes with tons of knowledge and tons of lexis and words that you need to use. And an example of this would be just a completely another language that I think most of us have been learning since day one. It's the language of math. And you're required to become very, very proficient in math to a degree where you have high level knowledge and you can use it very, very well. And finally, or second to finally, how does discourse communities save lives within industry, or within the engineering industry? Communication within the industry is vital in keeping everyone safe, because even though tragedies will occur, discourse communities will spread the case of and the reason why that tragedy or disaster happened, and it would allow others to learn from the experience that others have made and prevent themselves from making the same mistake. And this, because engineering is a pretty high level job that involves safety and people's lives at risk, will cause lives to be saved. Now, what is the future for engineering and its community? Well, the future is pretty bright. Deadly disasters will continue to happen, but the advancement of technology and safety standards have not slowed down. Just looking at the past lifetime, or about 80 years, the safety standard, just one lifetime ago, has been an insane amount of developments and so many lives saved. I mean, just think about the people building skyscrapers in the 40s. They weren't strapped in. They were just putting steel together. And many of them fell off, and many of them died. Thank you for listening and watching my presentation today. I hope it was insightful into engineering communities, or engineering discourse communities, and engineering ethics in general, and hope you have a good day.